In this module, we shall introduce orbits. An orbit of a permutation P is an equivalence class under the relation A is equivalent to B if and only if B equal to P raised to power n A. Here you can see that permutation is acting on A n times. For some n in set of integers z. And in the next module, we shall show that this relation is an equivalence relation. In this module, we shall see some examples of orbits. Find all orbits of the permutation alpha, which is given as 1 goes to 2, 2 goes to 3, 3 goes to 1, 4 goes to 5, 5 goes to 4. Method. Let S be the set that the permutations work on. Start with an empty list. If possible, pick an element of the set S not already visited and apply permutation repeatedly to get an orbit. Repeat step 1 until all elements of S have been visited. Here you can see that we are taking an example of alpha, and if you shall act alpha first time, you shall take 1 goes to 2, and if you apply the alpha second times, then you shall get 2 goes to 3, and then when you shall apply alpha third time, we shall get 3 goes to 1, and we are again come to 1. So we have in the orbit we shall have the elements 1, 2 and 3, and then when alpha x you can get 4 goes to 5 similarly, and 5 goes to 4, and you shall get in other orbit the elements 4 and 5, and we shall see formally in the next slide. Look at what happens to elements as a permutation is applied. Here alpha equal to 1 goes to 2, 2 goes to 3, 3 goes to 1, 4 goes to 5 and 5 goes to 4. 2, 3, 1, 5, 4 are images under the action of alpha. Here you can see that when we act alpha first time on 1, we shall get 2, and we can write it as alpha 1 equal to 2. And when we act again alpha on 1, and we shall write it alpha square 1, and you can see that alpha will act 2 times. At first 1 goes to 2, and then at second 2 goes to 3, and in this way we shall get alpha square 1 equal to 3, and alpha cube 1 equal to 1. Here alpha is acting on 1 3 times, and we have completed 1 cycle, and in the orbit we shall have 1, 2 and 3. This is the first orbit of alpha. And now you can see that when alpha act on 4 first time, if we shall obtain 5 because 4 goes to 5, and when we apply alpha square on 4, we shall get 4 and 5 goes to 4. And in this way we shall get the orbit 4, 5. And you can see that these two sets are disjoint, and what is the significance of disjoint sets in this case, we shall see this in the next module.